is n minus 1, so the number of pairs we have minus 1. So go to your A18 page in the book or a copy that you have. And we're looking at a degree of freedom of 7, and it's a one-tailed test, and it said that alpha was 0.1, or 10%. I got 1.415. George, are you good with that? Okay. So there's the edge of my rejection region. And now I'm going to do the formula from the first page, which is d bar minus mu sub d divided by the standard deviation of d divided by the square root of n. Now, when they do this in the book, they do it all by hand, and I don't see why we would do that. We do need the mean of the differences, the d bar, and we need the standard deviation of the differences. So here's what I would suggest, having your calculator do it for you, and putting in to stat. I'm just gonna, instead of putting in like the before and after into my calculator, I'm just gonna put all the differences in my calculator and do it that way. I'm going to type in 2, 3, 0, 1, negative 2, 2, 5, and 3. And then I'm going to hit stat calc, one variable stats. I could do this, by the way, the whole thing with a dependent test, but I'm trying to show you the steps. So my list is L1, calculate. Okay, so my D bar is 1.75, and the standard deviation of the differences is 2.12. See if I got that right. Oh, it should be negative 1.75, right? No, it's positive. Positive 1.75 and 2.12. You're saying what? Like you got something wrong?
Yeah.
Did you get S of X 2.12?
No, I think I typed something in wrong. I can't figure out what.
I'm only doing one example, so we'll wait for you. L1 should be 230, 1.
Oh, that's what I messed up.
Okay. Everybody understand where I got these numbers? Okay, now the score here is d bar minus mu sub d over s sub d divided by the square root of n, because just like all formulas, it's x minus mu over sigma always. So d bar is 1.75 minus
0.
Phew. Thank you. Minus 0, because that's a control group, and we're assuming that the control group, nothing happened to them. They had the exact same vertical height before and afterwards. 2.12 divided by the square root of 8. Put that in your calculator. I was teaching ninth graders today, and it was super cute because the ninth graders, and this is a true thing, I was showing them like how to reduce square roots today, how to break them down, and one of the kids in one of my classes said, "There's a button on your calculator for a square root." Whoa. And I was like, ooh, fancy dancy, this one. Like, just wait till I show you sine and cosine. Actually, I won't. I'm not teaching that anymore. Sad. Okay. So, Mrs. Sicking will be teaching advanced math next year. So, you are on video right now, Justin.
What do you mean?
I'm recording.
That's what I said.
Okay, so 2.33 hits over here in the rejection region. So we're going to reject the null. And in this case, accept the claim that the shoes... Okay, wait. Now we need to be very specific here, okay? Make sure that you never do what I was about to do on an AP test. Learn from my mistakes. Look up. Look up. I can't write that the shoes cause their heights to increase. Why not? That's saying why. So as a statistician, what you should be saying is, look, I compared these people to these people, and these people I can say statistically that they increased their jump size. It's not your job as a statistician to say caused by the shoes. It's to say, look, I investigated these people who didn't have the shoes and these people who had the shoes, and these people, statistically, their jump size raised. That is my information. A good statistician should never be able to be blamed by anyone for anything, because all we're saying is facts, where it's just like, look, here's the average. Like if you wanted to say this, they found out, for example, and this is a true thing, that hopefully you're not upset about me talking about. You don't hear about talking about abortion a lot in math class, but here we go. They noticed, like 30 years after Roe versus Wade was passed, that crime went down like 10%, like across America. And they found out that there was a correlation, not only a correlation, but a causation between basically women having an abortion and getting rid of unwanted pregnancies and the crime rate dropping. And that's because these children who would have grown up without a lot of parental support and people not wanting them didn't exist. And so then they didn't go to commit crimes. Not saying that just people who would have been aborted are the people who commit crimes, but these people who would have had families that weren't interested in supporting them, that they, just because they didn't exist, that's why the crime rate went down. And then a whole bunch of different politicians, this happened in the 90s. So a whole bunch of politicians started claiming that it was their policies that were making this happen. That like, oh, we're cracking down on crime and that's why it's so great here. And then they did a statistical analysis of which states banned, or not banned, but supported abortion, right? And allowed it to be legal. And in those states, you can watch the crime numbers just drop like exactly as they